welcome to this video on how many rubber bands does a water balloon need. So in this video, you're going to learn how to distinguish between an explanatory and response variable for quantitative data. You're going to make a scatter plot to display the relationship between two quantitative variables, and you're going to describe the direction, form, and strength of a relationship displayed in a scatter plot and identify unusual features. So the first thing to get this lesson started is you needed to have collected your data from the water Ziploc Bungee and have your distances travel listed here, okay? So if you haven't done that, pause the video, stop the video, go back and do that so you have some context to build this in. If you've already done that, let's talk about some of these things. So identify the explanatory and response variables. So your explanatory explains why something is happening. Explanatory. So for us, the explanatory variable is going to be the number of rubber bands because it's going to explain the distance. All right. Now our response variable, well, what is responding to the number of rubber bands is going to be the distance traveled. Okay, now how many variables do we have? Well, we have two variables. We have the number of rubber bands and we have the distance variable, distance traveled. So that's two variables. And are they categorical or quantitative? And they're going to be quantitative because they're numbers that can be measured. Quantitative. Okay, so in this spot, I want you to draw a scatter plot. So you're going to have a y-axis and an x-axis. And along the bottom, you're going to have 0 rubber bands, 1 rubber band, 2, make sure you get all 7. Okay, and then up the side, you're going to measure your inches. So this will vary a little bit for everybody. You want to scale it so you're still starting at 0. Remember, we still want to have a good graph. So scale appropriately here. So at this point, go ahead and stop the video and make sure you get your scatter plot drawn and then resume the video and we'll talk about it. Okay, before we go on to finish this out, let's go back and formalize a little bit of what's going on up here. So our response variable, which we said was the distance traveled, in general, it's the outcome of the study. Okay? Outcome of the study. Or in other terms, it could be called the output. And then our explanatory variable, which we said was the rubber band because it explains the distance, is used to predict. Just like your magic 8-ball, or we could call that our input. Okay. Now in your graph, you have to make sure that you've labeled what everything means. This is the number of rubber bands. So if you did not add that, make sure you do so now. Over here on the side is the distance traveled. And we measured in inches. Okay. And then the name of this graph is number of rubber bands versus distance traveled. All right, so you should have your plot on here. And having done this many, many, many times, I don't know your distances because that would depend on how much water you put in, a bunch of different variables here. However, in general, you tend to end up with a very linear scatter plot. Somewhere along this line. You may have a little variation, but it tends to look very linear. Okay, so if we're going to describe this, so this is similar to our socks that we talked about in Unit 1, where we talked about the shape and the unusual features, center and spread, but that doesn't really apply very well to a scatter plot. So there's another mnemonic I'll give you in just a minute, but just in general, what's happening? Well, the dots are increasing. They go up as they go to the right, which makes sense that the more rubber bands you have, the further your distance traveled is. Okay, so the dots are increasing. If we look at their shape, really, I mean, they're making a line. So we're going to say forms a tight, because we could have more scattered and that'd be a looser line. Tight, linear pattern. Okay. So when we talk about the shape of a scatter plot, you want to remember duffs. That's like socks. The D is the direction. And you're talking, is it a positive slope or a negative slope? The U is unusual features. Does there appear to be an outlier? And where would an outlier be for a scatter plot? Things we'll get into. The F is for form, and we're just really talking linear or not linear right now. And then your strength. How much like a line does it look? Our strength here is pretty strong. It looks a lot like a length, so we could say strong, moderate, or weak, or what the words we tend to use for how strong the relationship is. Strong, moderate, or weak. So when we look at what we wrote, increasing, that is our direction. So it's a positive direction. The form, is it linear or not? The tight was the strength. So we could have said strong. Okay. So, and unusual features would be an outlier. So in a scatter plot, a dot way out here would not be an outlier because it's following the trend. An outlier is outside the trend line. And we don't have anything out in the outside our trend line, so there wouldn't be any outliers here. So let's take a look at the back. So our explanatory, I've got two things I want to tell you here. So let's split it right about there so you have enough room. So we have our explanatory. Our explanatory variable is going to be used to predict. And then we have our response variable. It's the outcome, the response to the input, or the explanatory. Response to the explanatory. So your explanatory variable is your x variable, and your response variable is your y variable. Okay? So when you draw your scatter plot, make sure you name whatever your explanatory variable is here. you're going to want to put whatever your response variable is here. And your title is explanatory versus response. Okay? Now to describe, you're going to use defs. Okay, so we have a direction, and you're looking at either saying a positive direction, a negative direction, or you can't tell. Positive, negative, or none. Unusual features. So those are your outliers. Your form, you will say either linear or nonlinear. And then your strength. I want you to say strong. It really looks like a line. Okay, so your dots really follow a line. Moderate would be, you can see that it's a line, but it's a little more spread out. So if I had a line going through the middle of it, they're kind of spread out a little bit more, but that's moderate. And then weak, you can tell that it's still linear, but it's just really kind of spread out there. You're starting to lose the linear pattern a little bit. Okay? So that's our defs. Direction, unusual form, unusual features, form, and strength is your defs. So what I want you to do is I want you to pause the video and I want you to try this activity and then come back and check to see how you did. All right, let's see how you did. Is there a relationship between the amount of sugar in grams and the number of calories in movie theater candy? Here's the data from a sample of 12 types of candy. So I picked out the most common candies that you're going to see at the movie theater and got the sugar content and the calories. So we're going to make a scatter plot in a minute, but let's identify the explanatory and the response variable. So in this case, the sugar is the explanatory because it explains the calories. Calories is response. The reason that makes sense is if you add more sugar, the calories will go up. The reason it doesn't work the other way is just because the calories went up did not mean the sugar went up. It could have been another reason. So that's why the sugar is the explanatory and your calories are the response. And then I made my scatter chart, my scatter plot, and I didn't title it. So let me add that. Sugar versus calories. So we are complete. Okay. And so we can see it's got a positive trend because over here, if it has less sugar, it's got lower calories and it's generally going up. So we said it had a positive, fairly strong. I could have used the word moderately strong. That would have been a good word in there, moderately. Linear pattern, because it is, I can see where a line could go right through the middle of that if I wanted to. There is a possible outlier right up here, this guy. He's a possible outlier, and I went ahead and named what it was, that it was the peanut M&Ms and where it was located at 79,790. Outliers, remember, are outside the linear pattern. So if we had had something way over here, well, that's following the trend line, so I would not call that an outlier. But this is outside the overall linear pattern, so that could be considered an outlier. And in fact, if you cover him, like you can see the strength of the pattern is stronger because you have less of this pull out up in the calories. Okay, so hopefully that made some sense. If not, please give me a call at email at work, and I will see you in class. Bye.